Okay, welcome to Unit 2, Note 3. So today we're going to be learning how to solve systems in a more accurate way. So we're solving systems by substitution. So here are our steps. First thing you want to do is solve one of the equations for one of the variables. So just pick one and solve it. I usually recommend to students that they pick the variable that has a positive coefficient of 1. Positive coefficient of 1. Step number 2 is to substitute that expression into the other equation. So you have x equals something. You're going to take that something and you're going to substitute it in for x. It still means the same thing, except now it just looks a little different. So then you're going to, once you plug it in, you should only have one variable left. That's how you know you did it right. So you're going to solve for that remaining variable. The last thing you're going to do is substitute that value into either equation to get the remaining variable. So I know this sounds really confusing, but it'll make more sense as we're working our way through it. All right, so there are two solutions that you can get. You can get, first of all, get infinitely many solutions. So if both of the variables cancel out and what is left is a true statement, then the system has infinitely many solutions, or IMS. So when we were graphing, this is when they turns out to be the same line. So if we get something that says like 4 equals 4 or 6 equals 6, something like that, that's a case with infinitely many solutions. If we have no solutions, that means that both the variables cancel and what is left is a false statement. You have 6 is equal to 2 or 3 is equal to negative 3. Something like that. If it's false, then you have no solutions. So let's start this. Let's take a look at how this is going to work. So step number 1 is to solve the equation for one of the variables. Remember, I said to look for positive coefficients of 1. So take a second. See if you can figure out which one that is. Okay, so that x has a positive coefficient of 1. That makes it easy to solve for. So I'm going to solve, oh, that's hard to see. I'm going to solve this equation for x. So I have x plus 2y is equal to 8. So I'm going to subtract 2y from both sides, and then I get x is equal to 8 minus 2y. X is equal to 8 minus 2y. They are the same thing. I wear my hair curly one day, I wear it straight the next day. It's still the same hair, it just looks different. So what I'm going to do is I'm going to take this x is equal to 8 minus 2. I'm going to take that 8 minus 2y and I'm going to go into the second equation. And where I see an x, I'm going to put in that 8 minus 2y. So let's go ahead and practice that. So I get 1/2 times 8 minus 2y minus y is equal to 18. So I took out that x, and in its place, I wrote exactly what x is equal to in the other equation. Now all I have left to do is to solve an equation for y. So 1/2 times 8 is 4. 1/2 times negative 2 is negative 1y minus y is equal to 18. So now I want to go through my steps of solving equations to solve this for y. So I get 4 minus 2y is equal to 18. Subtract 4 from both sides. I get negative 2y is equal to 14. Divide both sides by a negative 2. And I get y is equal to negative 7. So now that I know y is equal to negative 7, I'm going to go ahead and I am going to solve this equation. I'm going to take and I'm going to resubstitute. So y is equal to negative 7. They're in the same thing. So if we look up here in this equation, we've already solved for x. We know x is equal to 8 minus 2y. So now this time, instead of writing y, I'm going to write what y is equal to, which is negative 7. So then I get 8 plus negative 2 times negative 7 is a positive 14. So I get x is equal to 22. So now I can write that as a coordinate point, my solutions that I have. I get 22, negative 7. So that's my answer. X is 22, y is negative 7. I know this is confusing. Okay, I understand that. Watch this video as many times as you need to. Practice some of these on your own. Pause the video and then catch up with me if you need to. So let's take a look at this one right here. So again, I want to look for positive coefficients of 1. You can really solve for any variable you want in any equation that you want. Okay, I'm just saying that if you have a positive coefficient of 1, that makes it easier to solve for. So I see that this x right here has a positive coefficient of 1. So I'm going to solve this second equation for x. Again, it doesn't matter which one you pick. I'm just trying to pick ones that make your life easier. So I'm going to solve that for x. I'm going to subtract 2y from both sides, and then I get x is equal to a negative 2y plus 15. Okay, so x is equal to that. X is equal to negative 2y plus 15. So I'm going to box it, and then I'm going to go to that other equation, the one that I didn't use. And wherever I see an x, I'm not going to write x anymore. I'm going to write what x is equal to. So I'm going to have 2 times negative 2y plus 15 minus 3y is equal to 2. So now I want to go through and I'm going to distribute and solve for y. 2 times negative 2y is negative 4y. 2 times 15 is 30. Minus 3y is equal to 2. Next thing I want to do is I want to solve this for y. So negative 4y minus 3y is negative 7y plus 30 is equal to 2. So I'm going to subtract 30 from both sides. And then I get negative 7y is equal to negative 28. Last thing to solve for y, I'm going to divide both sides by 7. And I get y is equal to a positive 4. So now I know that y is equal to that. Y is a positive 4. So I'm going to take a look back at this equation right here where I solve for x. Now I know x is equal to a negative 2y plus 15. So now that I know what y is, I can plug that in to get my x. So I have a negative 2. Instead of writing y, I'm going to write what y is equal to, which is 4. And then I'm going to add 15. So I get a negative 8 plus 15, which is equal to a 7. So I know x is equal to 7. So now I want to take and write that out as a coordinate point. Remember, coordinate points go x, y. So my solution is 7, comma 4. My x is equal to 7. My y is equal to 4. Okay, so I'm just going to get you started on this next one. And then I want you to kind of feel out where you're at. So we're going to have 7y is equal to 26 plus 11. Oops, I don't need to write that. I'll tell you what to solve for. How about that? I want you to solve the second equation for x. When you do that, you get x is equal to 3y. So I want you to take that 3y and plug it in for x right there. And then solve it. Okay, see if you can get both variables. Look back at your steps. I don't expect you to understand this 100% right now. We're still working through it. Well, I look here and I see that y is equal to this and y is equal to that. So I can take either of these and substitute it in already. So I'm going to take that one and I'm going to substitute it in there. When I do that, I get 3x minus 4 is equal to 4 plus x. So I'm going to solve that for x. So then I get 3x is equal to 8 plus x. Subtract x from both sides. 2x is equal to 8. X is equal to 4. I can plug that back in to get my y. So instead of writing what x is equal into the second equation, I'm going to write 4. I'm going to write what it's equal to. So then I get 8. Write that out as a coordinate point and you get 4, 8. Again, I'm going through this pretty quickly. Go ahead and pause it as you need to so you can take a look at what I'm doing and see what makes more sense. All right, but the reason why is I really want to get into some of these more challenging ones. So if we take a look at number 5, that second equation is almost solved for y, or x I mean. So all I have to do is divide everything by 2, and I'll have x is equal to 2y plus 2. Well, now I know what x is equal to. So I can take this guy right here, and I can sub it in for x up there. When I do that, I get 3 times 2y plus 2 minus 6y is equal to 6. So I'm going to distribute. 3 times 2 is 6. Y plus 6 minus 6y is equal to 6. Well, now we have a problem because our 6y's are going to cancel. And I'm left with 6 is equal to 6. That's where I look back at that original thing that we talked about. If the statement that is left over is true, like this is a true statement. That means that I have infinitely many solutions. So something similar is going to happen on number 6. So I want you to work through, start substituting, see if you can get your answer. You should either have infinitely many solutions or no solutions. See what you get. All right, so let's take a look. pause the video and go ahead and read through this word problem. Okay, so let's let X represent the number of 2-bedroom apartments, and Y is going to represent the number of 3-bedroom apartments. So that means that the number of X 2-bedroom apartments and Y 3-bedroom apartments has to be 6 because there are 6 vacant apartments. Okay, for every X 2-bedroom apartment, the cost is $700. For every Y 3-bedroom, the cost is $900, and that needs to equal $4,600. So let's go ahead and let's solve this equation right here for X, or for Y. Let's do Y for something different. So I have X plus Y is equal to 6. So I'm going to subtract X from both sides, and I get Y is equal to 6 minus X. Y is equal to that thing right there. So I can go ahead and I can plug it in for Y up in this equation. So then I get 700X plus 900 times 6 minus X is equal to 4,600. So now we need to solve that for X. Once you do that and you do some distributing, you get 700X plus 5,400 minus 900X, and that's still equal to 4,600. Okay, and once you solve that, we're going to keep moving. We combine like terms, we get negative 200x plus 5,400 is equal to 4,600. Subtract 5,400 from both sides, and you get 200x is equal to negative 800. So divide those out, and you get 4. And it's a word problem, so make sure you label it 2 bedrooms. So there's 4 2-bedroom apartments. Now we know there's 6 vacant apartments total. If 4 of them are 2 bedrooms, then logically there are 2 3-bedrooms. Okay. All right, let's take a look at number 8. So for number 8, this is just using math and putting it into words. Okay, so go ahead and pause it and read through it. So the larger of two numbers, 8, is 4 times the smaller. So I'm going to let Y be the larger one. And it is 8 more, which is plus 4 times the smaller. So 4 times that smaller number. And then if the larger is increased by 4 times the smaller, if the larger is increased by 4 times the smaller, the result is 40. Find the two numbers. Well, this is already solved for Y. So I'm going to plug that in for Y down here, and then I'm going to get 8 plus 4x plus 4x is equal to 40. So I get 8 plus 8x is equal to 40. Subtract 8 from both sides. 8x is equal to 32, so x is equal to 4. And now I want to find out what the larger number is. So I'm going to plug that in. I get y is equal to 8 plus 4. Now instead of writing x, I'm going to plug in that 4. 8 plus 8 is equal to, 8 plus 16, sorry, is equal to 24. Now I know I'm going through these, but we'll go over some of these more in class tomorrow. So go ahead and read through this word problem. I'm going to set it up for you, and then I'm going to have you solve it. So take a second, see if you can set it up by yourself. If not, I'll give you the setup. So I want you to solve this by substitution. Okay, X is going to be students per van, Y is going to be students per bus. So go ahead and solve this by substitution. Remember to label your answers. I want you to set this up and solve it entirely on your own. And we'll talk about it more tomorrow, but I do want you to try it on your own. See where you're at with word problems. You're not going to get better if you don't try them. Once you're done, go ahead and take the quiz.